I need to go to Zoom and share screen. Okay. Do you see my screen? Zoom. Can you check that? Because there is a projector issue is different and Zoom issue is different. I don't know why. Yes? You see my screen, you hear me. Okay. Good.
Good afternoon, friends. It's a pleasure to welcome Professor Arnav Bhattacharya from KFR and from UCSD KFR to give this lecture. The lecture would have organized on the 11th of November for the conveniences. The 11th of November is even though he himself did not receive for education or education and the first education minister of the he contributed by making bodies like UC, made by combining large number of smaller. Arnav has been around over here for a long time, but I can see some very young members in the audience who do not know him. Arnav is a experimental physicist is important in the part of many years. He's also someone who likes to tinker, likes to explore, likes to play around, and science communication is a passion for him. And I will not go through the list of awards and so on, but to say that I think that I have in the right place in the because it is coming about synthesis education. And today we hear about some of the interesting experiments we have been doing during the pandemic and working with
Thanks. Thanks. You can hear me?
Yes.
Great. So firstly, thank you very much for having me here. I have come to Mysore I have come to Punjab University and has specialized for CSIO and specialized for again for president and has specialized for the government I'm trying to expert. So that way it's very nice. And it's honor and pleasure to share with you some of the stuff that we've been doing during the pandemic. So I guess hello.
Okay,
I know what it's the Zoom thing, you need to click what's on the screen.
don't worry, don't worry. Yep.
It's okay, it's just a good. So, he's already given the gist of it. But generally, I am trained as a semiconductor scientist. I've talked about my work at ISRO before. But what I really like is to get the science out of the lab in the public. Usually in TFR, there's lots of higher etc. and something. So generally when things are going off the marks generally neat. First today I'm going to look more about the science communication and education part of my life. And one of the things is over the last 20 years I've learned a lot of things. I found I have to unlearn a lot of things, sometimes relearn new things or same thing again. One thing is you want to play this game of the position again. It seems to have gone on. Now that we know how to do it, is I must thank a lot of people that we are outreach. I used to do a lot of work taking science out to take the platform called position. Yeah, that's good. And I have been running something called Channel Y in the last almost 3 years. And Channel Y is a platform where we walk every Sundays and in the public, talk about something. And a lot of it actually we can translate it into stuff that can go out in rural areas based on very simple equipment, very simple things, mostly from that work. And this gave rise to this thing called the wonderful lab project. And that got translated to and some of this was actually in during the pandemic turned out to be something useful. Now, since I have been talking about Channel Y famous advertising because thanks to the pandemic, Channel Y is more accessible to everyone, even if they're not in Mumbai, purely online. It happened in Secure in Mumbai the first time we had sort of the best theater in Mumbai, knowledge improvement section, otherwise we're writing from here or somewhere else. And these are online. And just changes, more changes advertising, and this Sunday, I will be doing the chat part. Some of the interesting get history and history into your ammonia. It was amazing. More than half the atoms of nitrogen in your body came to this hollow process. This is not a very, very interesting. So what is science? Let's start with a very, very basic thing. To me, science is like the systematic effort we have made to understand the world around us. And that world could be the world inside a cell in my body. It could be the world of a set of planet or being a star of planets part of it. Okay, that's the world of science. And somehow, when I look at science happening in schools, what we are missing is the sort of the wonder of finding out that curiosity, that spirit of discovering something is gone. We have reduced time to this unfortunate subject that we do in school when we mug up something. If I ask a kid in high school what is science, most likely they tell me something. Something where you mug up the formula and switch. And this is not what it is. So we try to take science out of the lab, and by out of the lab means we've gone to any place where we could do science. So in Maharashtra, sugarcane grows. The sugarcane district is not just harvest even the site on the tree, where the store there sugarcane. We use those things as a place to do science, open air pandals. Some place where we didn't have anything at all, we used their room, the mattresses for their bed and use that as a thing. Since most of it is done at home, you can see, scientific equipment here, like a plate and an orange and also space, whether you available, you can go. For a long, long time, I was very conscious of the fact that I was in Myanmar. My job was science popularization, getting kids excited about science. We had a center, science education, which dealt with science. I have more knowledge of pedagogy, I have more knowledge of all these things. There are experts in science education, let them worry about it. I will get kids excited about it. Eventually, I discovered that there is no boundary between these two. Now, one of the most common experiments we showcase is we take a candle and cover it with a glass, and after some time, the candle goes out. And he asks kids, hey, what do you do? Everybody's thinking, the oxygen level. Why? Because that's what it is. So then you do a slightly different experiment. You take that same candle, okay, and you put you put two candles, and then you cover two candles. Now one candle goes off, the other candle is silver. So now you have a problem with the oxygen because, well, that original candle is gone off, but another candle is silver, all the oxygen will not be. Okay. Then you can do simple experiments like make a peace trainer. Please do not try this with a nylon peace trainer. If you're trying it at home, please use a metal piece. Okay. Otherwise, you will not get what to do further experiments. If you take a little slice, see how a single candle flame, via flame, whatever it is, you can look at how does it look at different levels. You can slice the flame and it's moving piece bigger up and down. It just cools it down that nothing else about it. And you will see, you notice, I'm sorry to point here once again, that this thing is hollow. Maybe I should use my pointer because that way, people in the online audience will also see that the flame is hollow in the center over here. Okay. Now, why is it hollow? I can talk about how candle flames or via flames are depending on the level, whether they are small kids or they're college kids or they're college students. I can tell them about the flames, how fuel and oxygen have to mix for something to burn. So there are lots of levels at which you can take this. And if I tell you why something is happening, am I getting into science education? Right? So this is a place where I found that there is no boundary. There is, depending on how you present it, what level of experience are you giving? Are you encouraging the people who are doing the experiment to actually think about what is happening? Are you guiding them towards thinking in the correct direction? So there is really no boundary, is what I felt. Now, we live today in what I would call very interesting times. And these interesting times have been not just today. I mean, you can go back 1859. 1859, the words of Charles Dickens, extremely relevant today. See what you know, right? It was the best of times, it was the worst of times. It was the age of wisdom, it was the age of foolishness, the epoch of belief, the epoch of incredulity, the season of light, the season of darkness, spring of hope, winter of despair. And I mean, this thing about there being in the world, we see so much of contrast, so much of, it's happening every time. I mean, some time back, there was this meme going around about people celebrating Har Ghar Tiranga, and where people said, where is the Ghar? If you look at, this is data from yesterday, but many countries have updated this. Last week update shows graphic differences only from October 9th. Look at the places where people have received, one dose of vaccine. You can see that a part of the world is quite empty. So there are huge disparities everywhere. And what do you do? So, my thing was, during the pandemic, can you do interesting but thought-provoking experiments even while people are sort of locked in at home? And maybe you can do these even beyond the pandemic. So this is where we started. And when I said you can do science anywhere and everywhere, home to me is wherever I am. And I spent last night at the ISER guest house over here, and I was making my talk, and I looked at, this is the ISER guest house room. There is a nice big screen TV on the wall. I actually must admit that I do not have a TV at home. I mean, I don't watch television at all. I'm not watching TV. I've never had a TV, so I've never observed these things. But there was a nice big screen TV, and there's a light at the back. The light is reflecting off the television screen, and it looks interesting, doesn't it? And let's look at this a bit more in detail. Now, kids, you can excuse me for a bit, but at least if you're ISER students and you see something like this immediately tells me that I can ask some questions to myself. Okay, I can ask some questions. I can look at, you see these rainbow patterns, but they're periodic. They're coming at a periodic interval. What defines this periodicity? Okay. You see two sort of an X-shaped pattern. Okay. What defines this angle? Right? You see that there is a vertical streak in the middle over there. What causes this vertical streak? From this information, can I tell something about what is the structure of this? I think it's an LED TV, right? Can I tell something about the structure of this TV screen? Here is something, I mean, this is something that you might see, but here is where, by asking the right questions, we can convert an easy observation into something where we can ask interesting questions and try to find out something. Now, this is an aside. All these television screens and all have laptop monitors, whatever, have polarizer sheets on it. The light is polarized. Never ever throw away a laptop screen. If a computer goes bad, the display goes bad, always break it, peel off the polarizer. You will never get such polarizing sheets for cheap. Okay. Once you have large polarizing sheets, you can do wonderful experiments. Either you have two polarizers, but even if you have one, remember the light from a laptop screen is polarized. So you can just make a white screen and use that as a polarized light source. You keep lots of stuff between the laptop screen and your polarizer, which you're storing from you can buy one if you want, but you can steal it from some local thing. And you'll see beautiful things. You keep plastic cutlery. You keep plastic cutlery, keep a plastic ruler, compass set, something. You will see amazing colors. Amazing colors. Why do these happen? Okay. And these are things which you can just do with very simple objects. Okay. And by the way, I mean, it's a little tricky to peel off this polarizer screen from the glass. Please be very careful because the glass breaks, it's sharp. But even when it breaks and you cannot peel off the polarizer thing, don't give up. Never give up is my policy generally. You take pictures and you send these pictures to art competitions. Okay, you get modern art. All right. This was my entry for the TIFR Art Festival. So never. So anyway, let's get started. So what we would like to do, this time we saw the example of the TV screen in the guest house last night. Look at simple observations around us, which I can develop into an experiment. Okay. By the way, please feel free to stop me and come me ask me, no problem. I will. So the idea, what I call an experiment is, we can ask some questions. Okay. Even better is if we can vary something. Now, I don't know, and the thing, I didn't vary anything. I just saw one picture I saw, and if I really wanted to find out, I should have varied the angle of the light or something, the distance, something, see if something changed. So the idea is you make measurements. Making measurements is critical to doing experiments and see if there is something that depends on something else. And hopefully, if you're doing things at home, you will make a mess, you will have fun. Very important. Okay. But please remember, all this thing, he said TIFR, I should say, it's the Tata Institute of Fundamental Research, because research is fun. Okay, we are a fundamental research place. So, my simplest thing is, how many experiments can you do with a sheet of paper? Okay, this could be a sheet of A4 paper, but I didn't want to tell my loading fast, but I found some newspaper was there. And you can do many experiments with that sheet of paper. So here is a sheet of paper. Okay. And the simplest experiment you can do with a sheet of paper. And I don't want this to work on. It's a pen. And there is the paper. Fine. I'm going to tell it in another direction. Let's see what happens. Did you see the difference? In one case, it tore straight. In the other case, it went all over the place. Okay? I didn't do any magic. You can take it with lots of paper here. Go home, take a piece of paper, all you do is store a piece of paper. Allow me now to tell people to think about why this happens. How do you make paper? You take pulp, you layer it, dry it. There are fibers of paper. If the fibers are aligned this way, and I tear in this thing, yes, I can tear between the fibers, it's easy. If the fibers are aligned this way, and I'm cutting it this way, it's likely to go in a zigzag manner. There are all we have done is one sheet of paper, but we can discuss this. We can ask questions on this. We can see if a sheet of notebook paper tears the same way as newspaper. There's a bond paper, a craft paper, a A4 sheet of paper. Okay. So you can now ask questions and make measurements. Then you can, of course, do so many things. You can try and fold a piece of paper, take a scissor, make a card. Hopefully, it's two equal ones. You pull it, they will not, both will not tear, only one will tear. Okay, figure out what. You can then, fold paper, stick it, make things called here, on one side and then, maybe double fold twists and then, well, you can do all sorts of fun stuff. You can ask people, well, how strong is paper? I give you 2 paper cups or do anything to water bottles. You fold this paper in any way you want and you keep it between the two. And we are going to keep weights on it and see when it collapses. And weights can be just notebooks or weight can be units of how many notebooks will it support the notebooks. And then you can see, does folding the paper in a particular shape help? Can I make what pattern of folding actually makes it stronger? There are lots of things you can do. Then one of my favorite things I use actually in the PhD class, experimental methods class, is to make paper helicopters. And this is one of my most favorite experiments. Sorry, I should be better prepared with this. Now I know that it's not going to tear nicely and you don't have a cylinder. I have to do something to force it to tear nicely. Not for that, but I have to. How do you handle it? Very simple. You take a piece of, so usually I use the 1/4 of an A4 sheet or 1/8 of an A4 sheet, so that 1 sheet of paper which makes 4 different designs. A helicopter is very simple. You fold a paper in half. Okay, freeze it and you tear it. I usually not use it. And you make some trees and you tear it again. Sorry, this is Yep. This is very, don't use it on the best. But you go to the normal notebook, it's the same. It is taken before coming down. Now you can decide that if I make different helicopters with wings which are big, I can take a long wing, short wings and a big body, long wings and a small body, one paper, 2 paper wings, and making variations. And see which one takes the longest time to come down. Which one is most accurate for coming up, but not get enough to fly off the wings. So there are different parameters we can take, and we can do experiments. In the PhD class, at least you come to memorization notes, but you don't need to get there. Even a simple experiment, you see that as a daily parameter, something else happens. This is a very nice, simple experiment. And by the way, so far we have not made the paper wet. This is all experiments with dry paper. If I make the paper wet, that's an entirely different series of experiments. Then I can do chromatography with newspaper and do so many things. This is just dry paper. And one of my favorite things with newspaper is to make models of the solar system. I will do this when we discuss the solar system will appear again later in the talk. So we'll do it at that time. Now we'll take a break from paper. By the way, if you want to watch the video, 1 hour video experiment only with the paper, that's the link. So during the pandemic, I had nothing to do. I used to do experiments with on Zoom, YouTube. So there is a YouTube thing. It's called tinyurl.com feet of paper. It's 1 hour of experiment with just paper. The other thing I would say is look at stuff in the kitchen. Okay, look at stuff in the kitchen. I'll give you the slides. No need to take pictures over there. So general warning is please don't waste food. Please do all these experiments before you start cooking. Okay, and define the menu for the day depending on whatever is the mess left behind at the end of it. Okay, and one of my favorite experiments is to look at how things are packed, because people study about solids and liquids and gases and all that, but we use grains in our kitchen. And not only do we use different types of grains, so you have, rice and moong and rajma and chana, and different types of grains. You also have the same grain of wheat, all the way from wheat to lapsi to rava to atta, which is the same thing but different particle size. And you know that it behaves differently. If you pour wheat, it flows smoothly. You buy stuff in a bag in the market and you pour it into a bottle. If you pour atta, you'll notice that it pours, it makes a pile, suddenly the pile breaks down and then pours again. If you haven't, please go and pour some atta and pour some wheat and check how they pour. They don't pour in the same way. They're the same material, different particle size. Okay. Now the question is, grains and granular matter are something which are completely different beasts. They behave very differently, they boggle the mind. A lot of very smart physicists have spent lots of time thinking about it, but you can do very simple experiments to see how they behave. And one thing is, when you put grains, how much space is between them? Okay. And one easy way to do it is to take 3 glasses and you fill one with, say, marbles, which are perfect spheres, something. And you guess how much space, even if I put marbles in a glass, is it more than 50% full? Is it more than 75% full? Is it 90% full? How much of space is it? Right? Something is there. Similarly, if I put rice, okay, does it pack? Does it need more space, more air space than marble, or much less? If I put some round thing like chana or something, will it have more empty space compared to the marble or less? How do you do these measurements? I don't have any measure at home. No problem. You have one more glass of the same size. You fill it with water. Okay? You fill it with water and you pour the water into this. And you see how much water you poured out. The amount of water that went in just before it's full is the amount of space that was there. You do a quick measurement because after some time the rice will start absorbing the water and swelling. Yeah. Okay, so before that happens, but you know how much water. I am not telling you the answers. Do this. Before you do it, you write what you think is the amount of space. And then do it and see what is the real amount of space. Something tells me that if you haven't done this before, or if you're not somebody in physics who knows about granular matter and the space between them, you will be surprised. Here is a very simple experiment. Okay. Again, if you want to watch simple experiments, there's another video of 1 hour which is called Simple Experiments. Okay. Working with food is always good. There is nothing like being able to eat your experiment. Eating your experiment is very highly likely. Especially when the experiment works or doesn't work, you can still eat. Okay, so 2 of my favorite experiments, one with chocolate and one with French fries. Kids love these things. Now, you like your fries nice and crisp and brown. Okay. Now the experiment is at the college level, effect of pH on browning. Or you can also call it like, if it is sour or not sour, etc. How does the browning matter? Okay, and this has implications on how we cook at home. But this is a very simple thing because potatoes are easy to get. Potatoes, it's very easy to take one potato and make some 10 bits out of it, which are reasonably the same color. In one of them, you just put some lemon juice for some time. In one of them, you put some baking powder for some time. This is alkaline, baking soda. Baking soda has not baking powder. Baking powder has a acid. And then you put them in a tawa and fry it. You can clearly see that there's a difference. The one with the lemon juice is not as brown as the one where the soda was. So you want to know the answer. But in Indian cooking, we often start off by putting oil, frying something, adding tomatoes. Tomatoes contribute some acid. They make it a little sour. That controls also the browning of your dish. So depending on when you put tomatoes, you can no matter what color of the gravy you get, etc. So there is a thing. The other example I have is on chocolate. Chocolate is always good to experiment, but still, you can do it with the one small 5 rupee chocolate thing and break it into bits and that. Now, I think many of you will have experience that you've got some chocolate, you kept it in your pocket or in the somewhere in your bag, and then you discover it after some time, the bag was already stuck, and you had also and then it's got this. What do you do? say, oh, okay, this is melting, let's put it in the fridge. You put it in the fridge to try and solve it again. And yes, it does solve it, it gets solved. Then you take it out, and what happens? It becomes harder to solve it. Harder when you become softer. Okay, so now if you are undergraduate in BSMS makeup class, they could talk to you. I have done this. I have done this experiment with kids at a child mind. I have done this with this example when I teach business. Okay, now it turns out that cocoa butter is one of the essential ingredients of chocolate. Sorry if you don't understand this for a bit, but it has 6 different polymorphs, 6 different crystal structures. Okay, one of them melts at about 34°C. And that is the one you want to stabilize, because that's the one you will melt in your mouth and give you a good, what they call the mouth feel of chocolate. Okay, the way you do it, so you have a complex thing of 6 different crystal phases of diagram of temperature versus the base. You cool it slowly. If you quench it, if you cool it very quickly, you stabilize another phase which melts at 17 or 18%, which in India means it's liquid alcohol. So if you take a chocolate and you suddenly quench it, what we are doing here is we have a ice water in a thing, we melt the chocolate and we just bump it in ice water versus we slowly let it slowly cool down. Nobody waits for it to slowly cool down. This is warm. But anyway, what the chocolate, even if it's a mess, even if it's liquid, it gets mixed up and there's nothing left behind. So you can see the difference. You can actually see the difference when you quench it versus something that you get different of chocolate. And of course, at a higher level, I can talk about this. So these are experiments which you can do at home. These are experiments which you can ask people to do, observe things, try and figure out what is happening. And by the way, if you heard of Lindt as a chocolate company, which is very famous, etc., which makes some super expensive chocolates. What is Mr. Lindt's contribution? He invented a process called conching, C-O-N-C-H. The equipment they use looks like a conch shell, it's conching. Read up about conching. It's the process that makes pure you get a nice, uniform thing of this butter phase, and that's why it's look at conching, and sometimes the conclusion of Mr. Lindt. So he did, probably didn't know about crystal structures, but he worked on this. Okay, so he did just a paper. There's another hour of just a piece of string. Okay, so there are lots of experiments you can do with a piece of string, and one of my favorite experiments is the spoon and razor experiment, for which we actually have stolen something from a vendor, and but I need. Now, just come up to the remedies. I am going to tentatively stop sharing the screen. Oops, sorry. Where's the Zoom? I know what happened. Please escape. Stop share. Okay, so let's see if you can do it so that wait, we should turn off the. I know what's going on. Let's remove blur background. Excellent. I'm also going to pin video so that this is just so that whoever is, it'll get. We can see what you're doing. Okay. So here is what have we done? We've taken a piece of string. I have attached a sharpener which I could find in her office. On this side, I attached a spoon, which he provided from home, I guess. So we have a spoon and a sharpener. Which one do you think is heavier? Spoon. The spoon is heavier. Come so that people can see you. Good. Okay, now what we're going to do is this. You hold this. This is going to be our pivot from which we're going to hang things. Hold this. Very nice. And we're going to put this string on top of it. Now I have a spoon on one side and I have a sharpener on one side. What do you think happens when I leave it?
It's going to go down.
Sure.
Yeah.
Nothing surprising, right? That's what you expected to happen. Oh, now let's do it slightly different. Again, no guarantees that this is going to work. This is not designed for things falling in this. Okay. We're gonna do this again. When you know this thing. Okay, spoon is there. This is there. Hold this. Hold this. See, now what we're gonna do is rather than earlier we were just leaving it this way vertical. Now we're gonna leave it an angle. Okay, hold this one. Very good. Good. Okay. Leave it. What happened?
Went wrong way.
Did you see it going down?
Yeah.
Never believe an experiment done only once. Okay, and never believe that maybe she had some magic in her hands. So let's flip the two people. When you hold this, that's my pivot. Good. Excellent. There you go. Awesome. Put it a little more because otherwise it's going to be around good. Wait, let's cut this off this place. We get stuck in the gap. Yeah. Good. Yeah. Go for it. Did you see? Did you expect this?
No, but I've seen a lot of people do it with bucket. That is the teacup. Once in
That's great to do it with the glass which is good. Now the question is, okay, this is the food of the day. But thank you very much. You just bring back the I stole your manja, very sorry. Now, if you are in the college level thing, I can start thinking about this as a proper experiment. I have a heavier mass and a lighter mass. Does this thing happen for all combinations of environment? Or does this, what happens if this is very light? Or they are almost the same weight? Is there an optimum ratio of mass 1 and mass 2 that is the matter and go around and get locked in? Is there an I know that if I give it this way, it must be equal. So there clearly must be a sum. If I do it this way, it's also going to straight down. It's not going to have a chance to fall and go down. So it has to be at some angle where it can actually make one term. Clearly the limits, if I hold it horizontal, it's not going to work. If I hold it actually vertically, it won't go down. So how does it depend on the angle of limits? This is an experiment. How does it depend on the ratio of the masses? How does it depend on the nature of the string? So there are so many parameters in this I can vary and try and figure out what is the limits of this particular situation. Okay, let's go back to screen share. Okay, oops. Then I have with string, I usually have a little, that string is too thin, but if you have a little bit of string like this, a little bit of string, you can do fantastic experiments on friction. So one is, I know the real world has go in Mumbai at least, most people go to Gateway of India and you see boats coming in, and you know how they move here. They take a rope, the guy with the boat goes a rope to the land, the guy takes it and just goes a few turns around some coast and the edge. They just move people in a very tiny amount. Okay, and this is something which used to always I used to think about it. And you can do this very easily. You can take a spray, you can attach, you need weights. So calibrated weights at home, you need to find out the handling for bottles of water. That's like a 200 gram weight. You can take a half liter bottle, you can half kilo weight, you can take a 1 liter bottle. Beyond 1 liter, the weight of the bottle is. So you have a 1 kilo weight or 5 kilo weight. Then you do the same thing. You can take a kind of convenient stick. Don't ask somebody to hold a 5 kilo weight. But you can carry it between the door and something, some rod. And you see, if I have a 1 kilo, how many turns of rope do I need to hold it? The friction holds it without any movements, right? And you see, by 3 turns or something, 1 kilo is easy. For 5 kilos, what will be? 3 turns, no. Just a couple of turns more, and you will be able to hold a 5 kilo. Because this idea, this is a very nice idea to look at exponential functions. Functions that grow in a manner which is like the fact that exponentially either pretty low exponentially. If you want to do more or less, you like something called as exponentially. Sure. Very wide audience. But even if it's cast on how much of the rope is actually touching the cylinder on which it is bound, so this is the part that is really efficient and what happens, etc. How much angular distance are you covering and how the friction behaves. So you can do a lot of very nice experiments with friction and with configuration of spring. Again, there's a 1 hour video. It's called Tiny World of Bit of Speed. Okay. Also, most of them are stupid experiments. They are experiments. Okay. Now, if you are in school, this is from the 6th standard Maharashtra State Board book of how the solar system is supposed to look. And most places, I think most books, they are unfortunately constrained by the fact that the solar system has to fit on a page in the book. So you have Sun and you have Mercury, Venus, Earth, Mars, Jupiter, Saturn, all that stuff going in one page. Now this is, and you can see the sizes also of the planets. I mean, this is completely misleading. Very, very misleading. Okay, so it's very easy to make your own solar system to scale. To scale. Unfortunately, I know we don't have too much time. I would love to do this activity, but I don't even have my solar system with me there. But suppose you make this right off. Suppose we made a 10 centimeter sun, 10 centimeter diameter sun. What would be the size of the solar system? So if you want to make a 10 centimeter size sun, very convenient thing is to go to the market and get a suit, which is around something. So if you're like me, I go with a piece of string, which is I look at the ruler 30 centimeters. Remember, the circumference is 2 by r. So if you have a 10 centimeter diameter, 25 to 10 is like 21.4. So about the length of the ruler is what we want. So I go with this and I measure it, and then usually the Halwala comes to me with stuff like chat. Something like guys, you know what I'm because I'm not looking at a food for whether it smells good or is right for something, but I'm making a diameter. Anyway, now he's given up on this one, he knows that right now I asked for weird things. So I get a food which is 10 centimeter diameter. Now, if the sun is 10 centimeter diameter, approximately, how big is the Earth? Where is it? Okay. And how big and where are the rest of the planets? So it turns out that these are the planets, and these are the planets, and again, over here, so that hopefully, so these are, the Earth is a mustard seed. The Earth is a mustard seed about 1 millimeter in size. Venus is also a smaller mustard seed, perhaps. Mercury and Mars, Mercury is 0.3 millimeters, Mars is around 0.4 or 0.5. These are, what I did is I took Rava and I hunted for Rava and saw a small bit of Rava. Mars one, I just put a red dot on it, so that would be Mars. Jupiter and Saturn are marbles. Kids don't play marbles anymore, but I mean, when we were small, we used to play marbles, glass marbles. So you find a marble which is appropriate sizes. Neptune and Venus are around 5 millimeters, 4.5 millimeters. These are just, this is the dried peas, Vatanas, they call it in Mumbai. So this is your solar system. Okay. Now, the fun stuff is to figure out how far the distance. Okay. And on this scale, so for me, the solar system was over enough. Now you can call them dwarf planets of Kuiper. So if this is the sun, 10 centimeters, where is the end of the solar system? Is it the end of the system? It's very not on the page. Is it the end of the system? Is it the end of I don't know, the building? No, it's where is it? Where is the Earth? If this is the sun, where is the Earth? How far away is the Earth? Earth, the end of the moon? No, not that far. So the Earth is probably a little bit beyond where it was. Is one mustard seed, that's clear. Then I think it's about 7 places from the Earth would be Mars, then from there 50 places, Jupiter is somewhere in between. From there, another 124 steps goes 1 meter across. So, something. So it turns out that the end of the solar system is almost half an hour. Where is the next node? Where is the next star? You're here in Chandigarh with this one star. Where is the next star?
Yes, Sri Lanka.
Near Sri Lanka, very good. Then you realize that space is very empty. And these are crowded parts of the space very empty. And remember, it's not just a linear distance. Even Earth, remember, this is the sun. Okay. The Earth is somewhere where they almost there, back. That's the Earth there, it's one square city. And you have little other marbles or a couple of other cities in the next half a kilometer of this side, half a kilometer of that side. So 1 kilometer here. It's not just linear, it's 1 kilometer and it's sphere. That's your solar system. In which all we have done is to find out what to do on one system. And this is really about what we eat, what we wear, what we value, what for one part of space. One thing astronomy does is tell you that humans are sort of insignificant in the universe scale. But the amazing thing is, you have the ability to learn. And you have the ability to so how do you remember how far our planets and this solar system is so big? With a sheet of paper. So this is another activity with a sheet of paper which we can all do. I'm not going to show you here. I am just going to fold this in half and half. Okay, here's the reductive form, and then we have a marker. Alright. Okay, so just imagine that this is your solar system. Okay, and do this at home. So on one end, I am going to write sun. Okay, on the other end, I'm going to write dwarf planets. I'm going to write Kuiper Belt Halley. That's the end of the solar system. Agree? That's the solar system. Now, if I fold this in half, okay, I'm going to mark a line over here. Which planet is here? Take a guess. Which planet is here? Jupiter, very good. Saturn. Good. Other people? Moon. No, moon is not a planet. Moon. This is sun, and the moon is not halfway between the sun and the moon. Moon is so this is somebody said Jupiter, somebody said Saturn, which is what this is. Okay, very good. We're going to mark a U over here because this is moons. Okay. Now we'll do the easy part first. We're going to fold the Kuiper belt onto Uranus. Okay, so we have 1/4 approximately, and we mark a line here, and this is an easy one. What is between Uranus and the end of the solar system? There's one planet here. Neptune, excellent. So I put an N over here. So now we have Sun, Uranus, Neptune. Now let's start this one. Let's fold Sun to Uranus. Sun to Uranus. I'm folding Sun to Uranus. And I put a line in the middle. Which planet is here? Mars. Jupiter. Saturn. This is Saturn. Saturn, very nice. Very nice. Let's fold the Sun to Saturn. Sun to Saturn. Who's here?
Mars.
Mars पे लोग पिता क्यों हैं? Venus, okay. Jupiter. Nice. Now we are getting it. Okay. So now you see how the solar system is shaping up. Neptune, Uranus, Saturn, Jupiter. Now we're going to fold Sun to Jupiter.
Sun to Jupiter. Who's there? No, it's the asteroid belt. Okay, let's put Sun to the asteroid belt. Okay, don't do this with so many times. Go to the sensitive of paper. Sun to the asteroid belt. Mars, yes, Mars, we've got Mars in the picture. So we've got Mars over there, and I am not going to hold it anymore. You can hold the paper and thirds over here. So you have your Venus, Earth, Mercury, and all of them. Okay. Now you see that the inner planets are in a very crowded part of the solar system compared to the rest. Okay. And that is the size of the solar system. That is how the solar system. Not, it is nowhere near this. Okay. Nowhere near this. Unfortunately, they have to put it on a page and they do this, but they don't write not to scale. They should write at. Okay. So this is an easy activity you can do on the sheet of paper. Tells you the relative sizes or relative position in the solar system. Now I have conveniently forgotten whether I did the pattern this. It fell down. Okay, yeah, I can see it. Okay, good. All right. Now we've been at home. We should go outside the house. Go outside. There's a whole world of stuff that you can do outside. So during the pandemic, we were looking for food, and one very nice source of food is drumstick leaves. I don't know if my wife is from South India, so we eat a lot of drumstick leaves, moringa. Very, very, very healthy, very nutritious. And sometimes you find at the back of the drumstick leaves, you find patterns like this. So you can ask yourself, who made this? Right? There are insects that make these. These are their houses, their patterns, whatever. So you see these very beautiful patterns on the backside of leaves, which you sometimes don't notice because you get it, you just wash it and see them, right? But notice these patterns. Notice the trees around you. There's this one beautiful tree around just outside the TFR gate. It's a laburnum tree that flowers just before the rains, and then the leaves go off. And you can see how do different laburnum trees in the city flower. Guys who get watered regularly by a gardener versus people who are growing outside. Is there a difference in their flowering? Do they flower always so many weeks before the monsoon comes? And lots of things you can do. Now, I like to use, I'm the type of person like science ke liye kuch bhi karega, as you will see in the next slide. But I know you can't do this in Chandigarh. Chandigarh is about 30 degrees north, I think. But if you are, a lot of India is between around the Tropic of Cancer and below, which means the sun is overhead at least one day a year. And you have what is called zero shadow day. So on zero shadow day, if you put a pole around, there is no shadow. And here is just a time lapse video. You can see the shadow decreasing from that side. At some point, there is absolutely no shadow of this pole. And it's really nice to stand that day and to see that there is no shadow. No shadow meaning it's absolutely below any part. And then the shadow goes on the other side after some time. So zero shadow day is a good excuse to talk about science. I use every excuse, as I said. So this is experiments on my own finger during elections. So during elections, people put indelible ink when you vote. Okay. And I don't know many people don't vote, but at least the ones who vote, you know that when they put it as purple, it becomes black after some time. So what happens? Okay. And I was pretty sure that this is something to do with the light. So in the what you see on the lower right corner, this was the Lok Sabha 2019 election where it got black pretty quickly. Okay, so in the next election, what I did is immediately after voting, I covered my phone. Okay, and I put it in my pocket. I didn't expose it to light. I came home, it was still purple. I had a bath. After an hour, it's still purple. After 115 minutes, I got sick of being, not letting it light. So then I went down and 10 minutes of sun and it became black. And I even left a small part covered with a tape to see that it doesn't become black because it's covered over there. So this told me that this is most probably a silver compound that they use. There is some chemistry happening and the silver compound is turning black. So this you can do at home. I do not recommend the next part of the experiment. It's not a lab called home, but crazy people. So I actually, what I did is I peeled off a part of my skin, which had this, and I took it to the electron microscope. Yeah, I put a little bit of skin. And I use the elemental analysis stain and stored that as well. Okay, you know, this is what you can use Twitter for. So there is a lot of science you can do now. What you can do when you have elections around, especially if your kids, and you're not voting, but your family members and parents are, it's a good idea to ask them to take pictures of their mail after a week, after a 2 weeks, 3 weeks, 4 weeks. You can look at the rate at which mail grows. Okay, and we are actually thinking of doing this on a pan-India level the next steps, because we think we can even look at the efficiency in a lot of people we can probably across India depending on just looking at it. So there is a lot of fun stuff you can do. Okay, wow. You can actually do some very, very cool science. This is, you know, again, don't need the resources as such. I am the chai guy and he was very good chai. So every morning I need chai. And the way I make chai is I take some back, whatever, and I pour hot water. And I cover it with a plastic, as it steams, I cover it with a plastic lid. When I cover it with a plastic lid, I can take pictures of it at different times. Initially, the steam condenses and forms very tiny droplets. After some time, the droplets increase. At some time, you will see droplets like this. We have a mixture of big droplets. There are a mixture of big droplets and small droplets, right? And I mean, again, this is for an MSc level class or something. Today, you have very simple tools like ImageJ. You can use ImageJ to take pictures of this, look at particle sizes, look at how particle size grows with time, look at things like Ostwald ripening of these drops and how it is eating up other drops. There are lots of, you know, really good stuff you can do science at a bachelor's, master's level based on observing how droplets that condense grow in size. The other thing that everybody seems to have these days is a mobile phone. Some of the fancy mobile phones, actually, this is not my phone, have pressure sensors. I have a Sasta phone, it does not have a pressure sensor. Now, everybody knows that tides happen twice a day. High tide, low tide happens twice a day. Most people do not know that atmospheric pressure oscillates twice a day. This is the lower graph. The lower graph is a typical measurement of atmospheric pressure in Mumbai. It always has a maximum about 10 a.m. and 10 p.m., minimum at 4 a.m. and 4 p.m. It oscillates. Atmospheric pressure oscillates every day. This is one thing you can study once you have a pressure sensor. Now, when a cyclone comes in, when a cyclone goes to a low pressure region or depression goes through, that change is so drastic. So here is the top graph is when the 10 p.m. the first peak, and then it just starts going down, 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 down. It's not huge down, and that scale is much more than what the scale is, right? So the daily variation is probably just from here to here. There's some very small variation, but here, when the cyclone came, it just went completely off scale. So you can look at sensors on the phone. There is a very nice app called PHOX, PHOX, which allows you to use all your sensors on the phone, magnetic field sensors, this sensor, raw data from XYZ accelerometers. You can do a lot of very cool science with that. And those who came for the talk in the morning have seen this already. You can do cool stuff at home, which is obviously. I didn't believe this, but I was working on masks, which is the talk I gave in the morning. And we figured out how to use heat and humidity to decontaminate masks. And we published this work. And we were publishing it on doing things, decontamination at home. Put your masks in a vessel, cover it, put that vessel inside another vessel, which is hot water. It heats up this thing and you can do your decontamination. We were trying to do multiple masks at a time. And the way we did it was, of course, we were doing experiments like this. But we said, why do one mask at a time? We will do multiple masks. And this, I use my idli vessel, the stuff we make idlis in. And this is now a figure in a journal paper with the data from the idlis, not the idlis, the idli holder, the mask on the idli holder. You can see the data, and so it's publishable. You can even do this. Okay. The other thing I do is I try and do low-cost experiments. One of the standard experiments for at least MSc level semiconductor work is the Hall effect. It's a very standard materials property measurement. The typical Hall effect setup that you find in a place like an IIFR is what you see over here. It's got some very fancy electromagnet. Of course, it's a temperature, I think, so we can cool it and all, but you have some very fancy power supplies, etc. Even if the cheap college level kits that they use, those are 25,000. So you set yourself a challenge. Can I do this for, 1,000 rupees, right? 500 rupees. And the answer is yes. So this is a visiting student and she is holding in her hand a Hall effect set. What does it have? It's this. Very, very simple. Nowadays, you don't need an electromagnet. You can buy magnets, permanent magnets. These are neodymium iron boron magnets, NiB magnets, which are very strong. They give a field near the surface of almost half a Tesla. So 2 magnets separated by a piece of wood, which has got a cut in it where I can put my sample. Sample is something which is a piece of silicon, which I have stuck onto a board and put epoxy on it with 4 wires so it cannot be removed. Try and make it as idiot proof as possible. This fits exactly snugly into it, so it's in between the magnets. You want to make a power supply. The power supply we make gives you 2 currents, 1 milliamp or 10 milliamp. That is it. We don't even use a PCB. We just bend the things and put tape around the body of the battery and a switch there to keep it there. Instead of having a fancy electronic card to switch polarities, we just have is that on? Okay, whatever. That doesn't. We've made a little better one, which gives you better current stability, but it's still pretty small. So you can make it. You can actually make it. We've compared the results with our setup and something for teaching people to figure out this N type or P type. Is it high mobility, low mobility? This is good enough. Okay. Last 2 slides. I am now at the Homi Bhabha Center for Science Education, which is a national center of TIFR, looking at education all the way from the primary level to the undergraduate level in science and maths, STEM education. We run many things, and there's only one thing I'll talk about, which is something called Anandi. Now, during the pandemic, everybody was, we're going to do online education. Why? Well, India's got 500 million smartphones. Data access is so cheap in India. But if you have 500 million smartphones in India, it means you have 500 million people who do not have smartphones. What about them? In villages, there are places where there is no network coverage, very poor coverage. Online education is not an option. See, most of our kids, if they have problem at home, we can teach them. We can help them go through their textbooks. In many places, their only access to somebody who could explain what is there in their textbook was in school. If they cannot go to school, there is no education happening. What do you do? So we decided we would have a good old newspaper kind of thing, a newsletter. It started off being one A4 sheet that was sent to people in some schools in Gadchiroli and Palghar. These are the tribal districts of Maharashtra. Now we decided that the cost of actually mailing it doesn't matter whether it's a black and white printout or you actually print it nicely in color. So now we print this in color, 8 pages. We are currently at 5,000. So it started from this. It's got a name. It's called Anandi. Anandi also is sort of a remembrance to Anandibai Joshi, the first woman from India to study modern medicine and get a doctorate. So this is Anandi. This is a color issue. It gets people. So after the pandemic, there's a lot of learning loss that has happened. People are forced to work at home. They've been working at home and generating money because that was what they needed during the pandemic. And now they don't want to go back to school. Especially we do not want, we've seen that dropout rates of women, girls are much higher. We want to try and do something about it. So this is something which is written in very colloquial Marathi. And it's got something very interesting. If anybody is interested, I have some issues here. So this is Anandi, and it's 8 pages. And along with it, there is a little insert of activities that they can do. There is an activity sheet. There's an activity sheet for them to do. And should they want to, there's a business reply envelope. They can just put it in this and drop it in a post box with compactors. Okay. And it is just amazing the kind of feedback we get. People, so this is at a Zilla Parishad school in Gadchiroli. People just write. They've got an opportunity to talk to somebody, to write letters. Right? They just write, they draw, they tell us what their life is about. Just people are writing. And that itself, I think, is quite amazing. We are trying to scale this up. This is something which we are just sort of doing on the side right now. It's not a formal project as yet. But I think this is something which is, to me, quite interesting. So I'm going to stop here. It's almost 5 o'clock. For me, this started off as trying to, I was a scientist in the lab. I wanted to get science out of the lab. I wanted to put the fun back in fundamental research. It's been sort of really addictive for me. And try it, I think, once you start looking at things and seeing, can I see some science in this? You automatically observe the reflection on the TV, or you observe something happening, or your election mark, or whatever it is. Just try it. I mean, and share the excitement with others. For me, often the thing is just looking at kids who are coming and watching what we're doing. The curiosity, the enthusiasm on their face, that's what makes it worth it. Thanks a lot. And I'm happy to take questions.
So in this program with Anandi, were you targeting any specific regions, schools, or with,
Gadchiroli, Palghar, Hingoli, Raigad. There are 4 districts where we are trying it out. Right now it is 5,500. Every month we are printing more and more copies because we want it more and more. The thing is, right now, even there are kids in Mumbai who want it. I mean, this is good material. We take some, and I think that at least in places like Mumbai, people who can afford the printing, it's always local. So, sometime back there was a solar eclipse, so this was about eclipses. Different issues cover what is happening around that time of the year. I think people who can pay for the printing cost should at least pay the. I can't distribute it free to everybody. So we need to figure out the economics and the logistics of how to scale this up and how to make it grow, because it has, I think the cross subsidy model is what's going to happen, because I think we have to figure out either CSR or some way of funding it. But if I write to DST for a grant, I'll retire by the time this actually takes shape. So I thought I saw a hand up there. Yeah, go ahead.
So I'm actually the most I've visited HDCC before.
Okay.
First of all, it's nice to see the amount of HDCC. And second of all, my question is, how can we as students contribute to their partners and when on our but you would also want, like, as in we're interested in science, which is why we're here. We would also want to get
So go out here. There's no dearth of kids in schools here. You don't have to go to Mumbai, right? Within 2 kilometers or 5 kilometers of IISER, I'm sure there are lots of school kids who would love to interact with you. One thing we found at Chai is there is a very large section of kids. It's now kids who pull their parents in. Okay, people are willing to wake up on a Sunday morning and listen to science. They don't know. They have lots of curiosity. They have lots of questions about science. It will be a lot of questions on black holes, things like this. Somehow astronomy always wins. But still, people have questions. They don't know whom to ask. Be that person. Be the person whom they can approach. I am sure within 5 kilometers of here, you will find enough schools and enough people whom you can reach out to.
So we have a strong outreach program. Number of schools and colleges come with us, and I'm sure the outreach is always looking for student volunteers who can spend time with them, interacting with them. So join that group. Let me know if you can figure out how.
Bug Amit.
Coming back to black holes, even astronomers get sick of black holes. So Professor Narlikar in his public talks used to end by saying, "I will not answer any question on black holes."
No. I mean, I am not an astronomer or something, but I have given so many talks in the last 25 years. I always get questions on the universe, on black holes, on somehow it attracts. Which is fine. If that is what is going to be the hook to get you into interested in science, it's fine. I always tell them that I cannot answer questions on black holes, Bermuda triangles, and whatever else. Some standard things which, and every time there's a movie like Interstellar or something, these things go off scale. But no, please, the answer is local. Think local. If you can make a difference to one kid around you, that's good enough. Go back to your, like TIFR has a scheme where if people want to go back to the school they came from, right? Go back to your own school and talk to them. We'll pay you, and we don't find people willing to do this. And we'll give you a free trip home. But of course, we want to make sure that we have vetted what you're going to say, and you're going to be not using jargon, and you'll be in a thing that fifth standard, if you're talking to the fifth standard, they'll understand what you're doing. So we do take that care. But please try it locally. Try it from the school you came from. Try it, in their local neighborhood. There's so many things you can do. Okay, I think you had a question, sir.
Can we keep any platform in the IISER so that we get people in Punjab, Haryana, and Himachal?
Right.
So how can we connect to IISER or the
We'll talk about this. So this dean outreach is the most obvious.
I mean, I think IISER is way ahead that you have a dean for outreach. I think the fact that you give outreach that importance is very nice.
Arnav also has to leave shortly, so I.
Shortly, we still have 15 minutes.
We can
half an hour.
continue chatting.
We can continue chatting outside.
Lots of fans, answers. So, we'll continue.
If we do, if it's